Welcome, everybody. Really appreciate your time today. We're here, very honored to have Andrew Krug. He's actually going to talk about memory forensics with kernel level ASLR. But before I pass it to Andrew, I wanted to actually take a moment with Sirox or Joseph to remind everybody of some upcoming events that we actually have in the next few months. On May, actually in just a month and a half, if you will, we're going to be at the RSA conference. So Joseph, if you don't mind, actually, can you give us some details about what is our participation there? What is the event all about? And what you're looking for in RSA?
Yeah, certainly. Thanks, Omar. I'm Joseph Malajanowski. I am part of the Red Team Village, and we are hosting basically 2 days. The 17th, we're doing a CTF walkthrough. We have a Red Team CTF that one of our team members is going to do a walkthrough, basically taking like a manager level person all the way through from understanding what a challenge is all the way to completing a challenge. And that's going to be pretty much all day on Monday for the Red Team Village. And then on Wednesday, we're going to be running a couple birds of a feather discussions. We're going to do some lightning talks, and we're going to have some demos of some products around Red teaming. And then Omar, Philip Wiley, and myself will be doing a discussion on our pen tester test dead now with bug bounties being available to everybody. So that should be an interesting conversation. That's going to be 30 to 40 minutes long. Audience is welcome to participate and interject as much as they want. And then also on Wednesday will be the second part of the CTF that one of our team member, Barrett, is going to be running. And that second part is actually more advanced. It's going to take, you're going to have at least medium level skills to be able to compete in that one. And there should be some prizes and stuff that we'll be announcing soon. So that's pretty much it for RSA. I forgot to mention, we will be running our stations during that time as well. So we have learning stations that you can pop in on Red Team Village or at texascyber.com. They'll be hosted in both places. You'll be able to basically go through one of those systems and learn a skill. So they're meant to be 30 minutes long, teach you a skill. The actual program themselves can go on for hours. There's enough material in each one of them that you can spend an entire day going through them. So look for that as well. Check it out on the redteamvillage.io website. So that's it for RSA. And then after RSA, we have Mayhem that is May 29th. Last year was our first year for Mayhem. Turned out to be a great success. This year we have a ton of people, ton of other villages getting involved in it. So you can look for, some really good briefings, some training, and some hands-on labs and stuff like that, similar to what we did last year. But it's about 12 to 18 hours worth of stuff that will be going on May 29th. So look for that. If you're a speaker or you have a paper or you do training, check out redteamvillage.io and fill out the call for papers.
Awesome. Yeah, and one more thing, actually, before I go into the next topic, we have a lineup of speakers already for these events every Thursday, at the same time, same bat channel, etc. But if you also want to present, or if you can recommend even a topic of discussion, you don't also have to present. We have a form within our website that you can actually submit that to. So, feel free. Now, next week, we're also going to have Harsh Brotha. He's going to be going over how to exploit misconfigured Jira instances for money. And that should be an interesting topic. And also, I know that a lot of you actually are asking about DEF CON, what's going to happen with DEF CON. Right now, I have no clue, right? So we haven't decided, and whenever I said not the Red Team Village, but the DEF CON as a whole hasn't decided whether it's going to be virtual, hybrid, or so. But there's actually definitely going to be more details to come. It is decided that it's going to be in August this year again, right? August 5th to the 8th. So just stay tuned for more details on that. And Joseph as well mentioned Texas Cyber Summit the Red Team Village will be a Texas Cyber Summit that's going to take place in October 29th and 30th. That will be a hybrid. If I'm not mistaken, Joseph, it's a hybrid event. We will have streams live, probably from the venue as well,
Right.
and we're gonna have a whole bunch of different speakers. And again, it's gonna be an on-site and a virtual event. So it's gonna be a global event, even though it says Texas Cyber Summit. It's gonna be a global event also for the Red Team Village.
Right. Last year we saw thousands of attendees attend from all over the world. We expect that same thing to take place virtually again this year. Our on-site one is going to be in person at the Marriott River Center in San Antonio, Texas. So if you want to join us in person, and it's going to be October, by that time everybody should have their shots and not have rabies or worms or anything. So they have all of you should have visited your vet. um, and we'll be able to hang out and see and attend and be able to see some speakers in person, get some hands-on training, visit with some people that maybe you haven't seen in a long time. So look for that on site as well as virtually.
Awesome. And with that, thank you so much, Andrew, for supporting us. We're looking forward to the presentation. Without any further ado, I'll pass it to you, and feel free to share your desktop and take it away.
Sure, thanks. So interesting that you say see your vet, because I think in Oregon, you can actually see your vet to get a coronavirus vaccine.
Oh my God.
I think that they just opened it up to pharmacists plus veterinarians, but don't quote me on that, unconfirmed.
Now that would be too weird. Here's my dog, give him the rabies shot, and I'll go ahead and get the coronavirus. Or just give me a Corona beer, one or the other.
Yeah, punch the card, punch all the cards. And,
Yeah.
I just want a cool printed tag, that I can take on the airplane. So the title of this talk may be slightly misleading. It's about, this talk is about memory forensics and kernel level ASLR. And it's more about why this doesn't work reliably most of the time, why this is kind of cool for red teams, kind of bad for blue teams, and just some things I've kind of been thinking about over the years. I'll try not to spend too much time on the wind up. I'm going to go, as close to 50 minutes as I can. This is the first run of this talk. And kind of like Brandon Sanderson likes to say, if anybody's a fan of Brandon Sanderson, sometimes you write 100 words a day and sometimes you throw them away. So this is kind of trying to figure out if this is a thing this community is interested in. I talk at a lot of cons about DFIR, about incident response, particularly in AWS. So hopefully that is of interest to you. So once again, I'm Andrew Krug. There's my contact information. You can email me, you can tweet at me. DMs are always open. I think there's kind of a perception sometimes in InfoSec that you actually can't just like DM people when you want to ask them for stuff. And I've been highly successful over the last like decade or so, just kind of like cold DMing. So please DM me. I'm watching, by the way, on my additional monitor, the Learning Thursdays channels in the Red Team Village discourse. And the guys here are going to help surface any questions from you. I hope we can kind of keep this interactive because it is streamed on Twitch and it is live. So like, let's make it live and less like a recorded talk. And my slides just really aren't advancing with the keyboard today. So I work at Datadog as a technical evangelist. I speak a lot for Datadog. This is not one of the times I am speaking on behalf of Datadog. These are definitely like my own kind of things. And not necessarily the opinions of Datadog. Really, I've done a lot of work in the memory forensic space. If you've heard of tools like Margarita Shotgun that are cloud wrappers around Lime, built that years ago with a guy named Joel Ferrier, and it was a fun time. I'm also doing some teaching upcoming for Wild West Hackin' Fest. This is my one shameless plug here. I guess there's one more after this. If you're interested in cloud security fundamentals, you can sign up there. There's two upcoming deliveries for 4-hour sessions. And I'm also hiring technical evangelist security advocates for my, not this talk job. So if you're interested in a career in security advocacy, definitely reach out to me. If you don't even know what that means and it sounds exciting, or you like to give talks like this, let me know. I'm on the Discord. So kind of the truth here is that I want to give this presentation to you, and I would love for 10 or 50 or 100 people to come out of the woodwork and tell me that I'm totally wrong about every assumption that I've made on this memory forensics problem I've kind of been working on for the last like 4 years or so. So please definitely tell me if I am totally wrong about any of this. Again, let's chat. Let's chat in the chat. I'm watching the chat. I see a couple of chats come in here, but they're from the organizers of Learning Thursdays, not from any attendee yet. So somebody should be first. The things I hope that you take away from this is why, as incident responders and defenders, do we even want to do memory forensics at all? That has nothing to do with KASLR. But like, why is this interesting to us? How is this thing broken that was historically once helpful for the community? And then what can you do to help or not help if you're in the business of like red teaming or trying to cover your tracks? How can you kind of like sidestep some of these things that we do to get memory forensics, or what we refer to as live response happening on systems, right? So let's start with the first topic, right? Which is, why do you want to do memory forensics at all? Forensics has kind of come about as this discipline, you know, where we used to actually go to in person. If you're law enforcement or industrial forensic examiner, you'd actually like go into the data center, right? And you'd like pull out the power cord of a box, and you'd take all the hard drives out one by one, and you'd image them, and then you'd kind of try to put back together the Clue style story of who did what. And, you know, why particularly do you care as a red team and the red team village? I always put this quote in my presentations from Harry Potter, which is that, you know, you want to think as dark wizards do. And so if you're a red teamer, you want to think as defenders do in order to improve your attacks. How many times have we said, you know, oh, that looks suspicious that I'm base 64 encoding, you know, this payload using PowerShell. Well, it turns out SCCM does that all the time. So the more that you learn what normal operations defense teams use to push out payloads, the more you can make your attacks look normal and find different ways and kind of places to hide. So this is one of my favorite quotes. Any Harry Potter fans, you know, feel free to just throw a message in the chat. So back when I started like in this field, it was probably like the mid 2000s. I had the advantage of like going through a NSA Center of Excellence style kind of program track of here's how you do forensics for law enforcement. And we used to use devices like this. That what you see on screen is a Tableau write blocker that would prevent you from doing things like tampering with data on disk when you were actually analyzing or making a copy of the disk, and it's a hardware device that did one very, very specific job. As things have kind of spun out to cloud compute and data centers, you know, sort of went towards virtualization. Of course, these things all moved into software, and they became more and more complex. So then there was this live system forensics train that sort of started, and live system forensics was a big change, like in the industry, right? Because we started to think about this idea that as hard drives were getting bigger, it was taking longer and longer to kind of analyze what was going on over time. So people started making things like what we used to call knife disks, and they were USB flash drives that would like auto run in Windows, and they used some of the same facilities that we weaponize for attacks to collect live response payloads, like things that were going on in the system. And volatile memory was just kind of really starting to be a thing in the mid 2000s. So I don't know if anybody here has ever used F-response for anything like that, but that was one of the really super early players in kind of the forensic space. And then this book came out, which kind of broke the live forensic scene, right? And this was The Art of Memory Forensics. And it was the go-to kind of guide on like, why do you even want to do this? So some of the things that are brought up in this textbook, which is by Andrew Case, for example, Jamie Levy, Aaron Walters, Michael Hale Line, I think it's pronounced. These guys really like pave the road and set the stage for this. And this is actually still, believe it or not, the authoritative textbook. Nobody's written a better book than this since 2014. But it really just goes to show you all these things that you can't really figure out by doing disk forensics or doing traditional live response. Things like RAM scraping, which if you've paid attention to the headlines, you can't detect RAM scraping on credit card devices without going to memory. You can't detect fileless malware, which is getting to be, more and more accessible to more people. And then there's a ton of other artifacts that applications, by virtue of the fact that they're trying to do security better, those things only live in memory now. They never actually go to disk. So if we're only looking at cold systems, we're only getting like this teeny piece of the puzzle. I'll just stop there in case there's any questions coming in that we want to surface real quick. I'll just pause. All right. So no questions yet, but in the good old days.
Sorry to interrupt you, Andrew. So I'm also monitoring, of course, YouTube, Twitch, and a few other places. So for everybody that actually has just joined us, the Discord server information is in the bottom of the screen. It should be in the screen and also in the description of both YouTube and Twitch. And there was actually a question that was IM directly to me that is mostly around how to actually get started. If there's any capture the flag type of events, I assume that you have some type of a collateral information like that. But I'm gonna try to conglomerate some of those questions. So I know that some of you are actually already asking some things and you're pinging me, one-on-one. We will probably address some of the questions at the end. One thing that I want to highlight is that there's also a around 40-second delay from whenever we talk, and they're actually able to ask the question or we're able to answer it. So we just keep in mind of that. So with that said, that was the only question that I have received so far.
Yeah, sure thing. And I'm happy to give getting started recommendations kind of here at the end of the deck. I'm also happy to show off things like what does work for me, what doesn't work for me, et cetera. So keep those questions coming and we'll kind of look at it at the end. Awesome. But kind of getting back to the mid 2000s, right? And normally I hate it when people tell stories like this about like the good old days, but this is super important, right? Because the reason that we liked live memory capture in the mid 2000s, and the reason that the creators of all these frameworks wrote these books was because it was so much faster to actually do analysis on a system and produce kind of the report of who done it. You could break the case, using memory or live system long before you would have to spend tons and tons of time crawling through what were at the time spinning hard drives. And that took a really long time. We had platforms like Ncase and Access Data FTK, and those just got bigger and bigger and more expensive the more drives you had to analyze. So you mem capture plus an analysis tool equal to a really great report that could churn out super fast. But it's not really that simple anymore. And we can kind of blame it on the arms race that's really, kind of this red team, blue team thing. And maybe you have thoughts on this that you want to share, which is that, sort of as attacks advanced, the defensive technology kind of has advanced, and some of the security measures that we had to put in place in order to mitigate certain kinds of attacks have broken this style of forensic tooling. So what happened? Effectively over the last decade or so, really in the last 5 or 6 years, this has really matured and become more of the default in OSs by cloud providers, is that operating systems implemented ASLR or KASLR. And one of those is far more difficult to do forensics on than the other, right? Where ASLR is address space layout randomization and KASLR is kernel address space layout randomization. And these are randomizing the offsets where the bootloader loads processes. And so if you think about ASLR, that's like inside the context of the operating system itself, like where Windows puts specific things that you can kind of anchor to. And KASLR would be changing the offset of where PID 0, process ID 0, or the kernel is loaded into memory using some sort of advanced firmware, bootloader, et cetera. I mean, that's like the 30,000 foot view. If you don't know anything about hardware, you don't know anything about how bootloaders work, that's totally okay. But basically just like understand that these things that were once in very predictable places that powered forensics are no longer really in these predictable places. And I like to talk about this attack from 2006. I don't know if anybody's ever heard of it before, called the Boileau attack, which was using iPods, right, to pwn Windows. Maybe you remember this. It was kind of the talk of the town when I was in school, back when FireWire was a thing. What you would do is you would kind of hack the iPod, and you could pop it in a FireWire port that had direct memory access, and it would progressively slide through memory, and it would look for the signature or predictable address of the Windows logon GINA, which is the logon screen. It would overwrite that space in memory to allow you to put in no password on a lock screen, which was a very, very cool demo to do in front of people. So yeah, it was awesome back then to pwn Windows with click wheel iPods. But of course, none of this is possible anymore because FireWire is dead. We have address space layout randomization. We have all these different security measures in place that sort of mitigate the style of attacks, but this is kind of the golden age of using memory for good and for evil, because at the same time, these kind of attacks were coming out in industry. So was defense playbooks. People were writing playbooks that was like, hey, you can hack your click wheel iPod and you can take it to your data center system that for some reason comes by default with a FireWire port, and you can just dump the memory from it. And then you can go do forensics on that, which was cool in a sort of unique way. So again, like this really worked for a few specific reasons, right? And that's that if you look at this graph on the right here, things were loaded into very predictable locations in memory. And memory was also very, very small. So one of the things that you have to keep in mind is that Moore's law here really applies. Anytime that we talk about the exploitation of memory for attacks, it's kind of an arms race of like memory is increasing. Maybe it has a higher rate of churn as well as like system utilization kind of goes up. And the cost, the game theory cost of actually attacking that space gets higher and higher the bigger that space gets. So this is just kind of a snippet from AWS, right? So instance sizes are increasing, and I particularly deal with cloud compute, right? So I speak a fair bit on AWS hardening and forensics in the cloud. In AWS, of course, like one of the most popular platforms that you can run is Kubernetes, and you're incentivized economically as a business to put as many things as you can to kind of get your instance to maximum utilization to drive down cost. Here in the slide, we just have 3 different instance sizes. So you can see that one Kubernetes node could be as large as like 64 gigabytes in an average case. And there are instances that have far more memory beyond that. So when we talk about an enterprise, which is different than like pwning an endpoint, we might pwn thousands of systems as an attacker. And as a defender, we might have to find the needle in the stack of needles in all those different memory dumps. And so anytime that we have to guess at something, and that's computationally expensive, we're disincentivizing the blue team economically to actually do the right thing. And that's kind of the situation that we're running up against as we talk about strategies for mitigating KASLR in memory analysis. And I'll talk a little bit more about that, but there's complexity here. And anytime that we're virtualizing, it adds complexity. Anytime that we're adding Docker containers on top of that, it increases complexity. And we're having to write more and more compute intensive plugins for these memory analysis frameworks to just like dive in and actually find the signature of what we're looking for. And that could be a variety of things. So the TLDR here is that if we have to somehow brute force out, because KASLR exists, the process ID of the kernel, that is highly impractical at any scale beyond 1, right? So as red team, it's a yay. As attackers, they could say, wow, if I have these specific tools that target memory only in a specific way, it's going to be very, very difficult for an IR team to go back and understand things that were in volatile memory after the fact. And depending on the size of your fleet, this could be a lot of time and compute and disk, even if you do have those memory captures to go back to. So kind of the bigger you are, the bigger a target you are, but also the more expensive that problem becomes. And so I just want to kind of stress that, because I like the game theory of this, because we're as attackers, you're generally going after large targets. So how do we get memory off these boxes as defenders in the first place? So there's a bunch of existing open source projects out there. I don't have any commercial tools on this slide because I think most commercial tools are probably also built on these projects, and they have the same kind of shortcomings. I'd love to be wrong. If you have a commercial tool that you really love and you want to share that with me in a DM or something, happy to hear all about it. I've previously built tools on the Lime project, which is a totally well-maintained project that people use for DFIR and Linux in the cloud all the time, but it was actually built for mobile phones. It was built for Android phones. And so there's some things there, like project trade-offs of keeping the acquisition kernel module small, but also like not necessarily pandering to the fact that this is on a bunch of server systems. There's WinPmem, LinPmem from the Google Recall project, which is an older project that also hasn't seen a lot of activity in the last little while. And then kind of an up-and-comer tool here in the Linux space is AVML from Microsoft, which is a great tool. It seems to do many of the same things that Lime does. It's written in Rust. It's user space. I'll talk a little bit more about that later in the demo about why it's cool. But there's a bunch of stuff out there. So we have let's just kind of like walk through this demo. And this is slide based. Like I'm not going to switch out from like terminal back and forth, back and forth, back and forth. At the end, if you want to see me do stuff live, I've got an Amazon EC2 instance with kind of the tools loaded up. It's wildly unsensational just to see memory get dumped because you just run this command. But kind of what we have here in the Linux space is these two tools, Lime versus AVML, which, Lime is probably the oldest and one of the most popular tools, because kind of what it ends up being is a kernel module. And so it has to be built for the running kernel of the system, which is already kind of a disadvantage, right? Because do you really want to think about doing forensics every time you patch your systems and update to a new version of a running kernel? For a while, I maintained a set of tools that would just build this for every running kernel that was possible in Linux. I was like, I can DevOps my way out of this problem. And it turned out just to be this massive problem to just keep this going and building all these different kernel modules that you could insmod in order to get memory. It did have the advantage, though, because it was a kernel module, of being able to acquire things that existed in the kernel space, which is a very fancy way of saying that Lime, in this case, because it acquires memory through being inside the kernel itself, a kernel module, it can know things that user space memory acquisition tools can't know. So AVML, for example, works in user space, which means that it has some different rules that it has to play by. So it can dump /proc mounts, the hardware mounts that are actually in the file system for getting access to memory. So the classic one in Linux right now is /proc/kcore, which is an ELF binary representation of all of memory and the kernel itself. So all AVML can do is dump that to a file in the right format. But because that's a user space tool, if you have pwn to box and you have control to manipulate the kernel, you can also lie about what AVML gets from user space. And so we kind of have this double-edged sword of compatibility and its ability to kind of see memory as it is versus the kernel module that sees, kind of the raw set of payloads. And that's kind of a problem because we can't always trust what the tools tell us. And from a forensics perspective, as examiners, people doing forensics, we always want to build this custody chain of what actually happened, how did it go on, and can I reproduce the steps that I went through in order to tell that story over and over again. And memory analysis is this very squishy, very uncomfortable space sometimes when it comes to analyzing different types of attacks, especially in cloud. So this is just a quick GIF here of performing a capture in Lime. So I'm on an actual EC2 system itself. I've got that kernel module all pre-built, pretend I'm the best blue team in the world, and I warehouse these. Every time I patch the kernel, I go and I run a job automatically that just goes and generates these. And then when there's an incident, I can get it onto the box and it can generate a file. And then I can somehow get that file off the box to a secure location for analysis after the fact. It's a bunch of steps. It's a lot of orchestration, especially when you talk about doing this across a number of systems. And I can't stress, the number of systems problems is so real for so many people. And you can see there, put out a bunch of different mem captures. So if I can do all these things in Amazon Linux or in Ubuntu on latest Linux kernel, do I win as a defender? Do I know all the things? Nah, not most of the time. Because if I take these dumps and I put them into the most popular memory framework, Python volatility, even with some of the plugins that can go in there and they can kind of hunt for PID 0, I still get mixed results for these. So like KASLR and performing dumps at this level, depending on the OS you're in, maybe that OS is really, really supported. Maybe you're using container-specific Linux. Even though these things are all Linux, the way they choose to implement the nuance of KASLR is a little bit different. And it's different enough that it creates this analysis problem. So what do we do now? Like, if we can't do that, right? Are we totally hosed here? Can we just not use memory to tell these stories? The volatility project would say that the answer to this is to use volatility profiles. So basically, think of this as a map of where things are going to be loaded for the running kernel that you have on the box that you have. And if you have done the planning, or you can make a copy of the box, or you can get on the box that you're trying to analyze, you can make one of these. And I've tried to orchestrate this too in the past through like all kinds of different automation and kind of generate one of these map files, which is the combination of the profile and the kernel headers. But this doesn't work super well either. I say it's painful but practical, but it still only works a little bit of the time. So we can go off and we can build these things, and we can get the build tools onto the box, which is already like corrupting the state of the box, which as a forensic examiner always says to me, I've done wrong here because I'm putting so many things on the system. I'm tainting the state. And no longer do I have kind of this pristine environment where I'm coming in and trying not to add my own changes to the system. So we make all these assumptions that if we just do the dance right, we assume that the box has outbound internet. We assume that we can install dev tools. We assume that we can compile something, then zip it up, then get that off the box if we haven't done it in advance. And I mean, I don't know what kind of environments you're in or how many people are in environments that are 100% homogeneous, but you also have weird things that get pwned too. So whatever your DFIR playbook is, probably has to work for those too, not just like the 80%. It has to work for the 1% that might be the pivot into your enterprise. We can't do it because it's not really forensically sound. And I know as incident responders, oftentimes we're dealing with crypto mining, we're dealing with ransomware, we're dealing with all these things that I would refer to as annoying. But, if we want to ever litigate, if we want to take a case to court, this isn't going to hold up, right? Because the tools aren't validated. You don't necessarily have a complete chain of custody for it. Probably would end up having to bring in expert witnesses of all kinds in order to see this through all the way to the end. And even if you can, the jury is going to be super, super confused when you kind of explain this. So hopefully your expert witness that you bring in is just great. So if you do end up in one of the scenarios where you've gone to all this effort, it may actually still not work. And that's kind of the hardest part about it, is that you can do this and you can write the code and the plugins that will progressively slide through memory, and they'll find PID 0. And if anybody's interested in that kind of presentation, how we might be able to predict the location of that using heuristics and stuff, I could do another like deep dive advanced talk on that. I'd hoped to do it for this one, but I didn't have a super lot of time this week to throw this together. Just let me know if you're interested. If memory forensics is a passion of this community, happy to put the time in. So as an attacker, you can actually take advantage of the fragility of this process, right? Which is that when you pwn a box, if you are highly privileged on the box, of course, you can get rid of the maps that a responder would need in order to build their volatility profiles. So that means they have to go all the way back to their like original machine image. So if it's in VMware, if it's an AMI, if it's a GCP image, whatever, they're gonna have to go all the way back in order to pull those maps out. And they may still not be the actual latest running kernel, or they may have to spend a lot of time running down what the latest patch level is of the box. Hang on one second. I have to grab my cat off my desk before she pulls my microphone onto the floor. So my cat loves to be the star of every talk. You can also insmod modules that that blue teams are going to use. So a lot of the DFIR playbooks that people use are just bash scripts because security people aren't always necessarily coders. They don't write idempotent code by default. They're not programming at the same level as engineers at HashiCorp. They assume that the Lime modules don't exist on the system, or the file doesn't exist on the system. And so by kind of name stomping those things, you can prevent the memory capture from ever happening at all. Like forget anything fancy. You can just kind of sidestep that. So insmod anything that's called lime.ko with kernel module lime, and boom, you basically have totally hosed the forensics process. They're not going to get a capture from that box unless they've gone way out of their way to validate their process. And I don't know how many incident response teams actually have end-to-end CI/CD style testing that's the same as what they would probably do for the software product that they're building. You can also do anything, totally obvious if you have access to the box to overwrite mem by just using /temp to corrupt, swap, etc. For covering tracks. So that Microsoft project, I left an extra bullet on the slide. I never do that. But AVML is that Microsoft project. It's very cool. It has a lot going for it. It's a user space tool, like I said, so it's subject to memory corruption attacks. But the advantage of this tool is that, in my opinion, it's built in Rust. And if you know anything about Rust, I don't know if anybody uses Rust, they want to just throw an emoji in the chat or the Twitch chat to give Rust some love. I used to work at Mozilla TLDR, so I like Rust a lot. Spent a lot of time thinking about Rust, but this is really fast. Like it is 3 or 4 times faster, probably, and that's anecdotal, in actually dumping out the memory capture. It includes compression using Google Snappy, which if anybody's a fan of Silicon Valley, Snappy uses that metal out compression thing. It's real. Snappy is very efficient, and you can go back and forth between AVML dumps and other formats. Unfortunately, this still also seems to have many of the same problems with actually just being honest, even though it uses the /proc kcore mount point to dump that ELF binary in volatility, at least. If you don't want to brood out the result of where PID 0 is for every single dump, you're kind of in the same place, which is that you have a analysis pipeline now that doesn't scale with the problem that you're having, which is a really, like, if you're in an incident of a size, again, that's greater than 1, this is going to ruin your day, or it's going to ruin whatever contract company you have on retainer's day. So for attackers, it's totally great. So if you're looking for, beyond certain kernel versions, maybe you have to worry about less about memory analysis than you do about disk forensics. This is what it should look like. And I just snagged this off the Volatility Foundation. Oh, this GIF is not going to play, is it? Spend that kind of a day. But basically what you should see here is just an example of when everything works. And the profile knows where to go and get a thing. It should be able to dump a process list for starters. There's all kinds of other artifacts that exist in memory, like the hashes of executing or executables in memory, the netstat table, all these super useful, very rich artifacts exist resident in memory. So we think this is cool, right? Like as an ecosystem of defenders, attackers, responders, analysts, whomever, we think this is cool. But this is built on all these open source projects. And these open source projects are often love labors of folks like me and folks that are far smarter than me, that spend a lot more time on these. But they get lots of issues and not a lot of contributors. And this work is incredibly tedious and very hard to do. So we kind of have this economic disincentive almost to come in and address these flaws as operating systems are kind of ramping up security features. I don't know if anybody has seen the most recent announcements from AMD, which is that the next generation of AMD processors will actually encrypt memory at the chip level. I have no idea what that's going to do for kernel space memory forensics or bootloader based memory forensics. Or we're going to need like TPM style shims for like lawful intercepts. I actually don't know, but now is the time to start to kind of think about this and address these issues more, not as hobbyists that are building tools that close gaps, more at the Linux kernel level, the hardware level, the data center level. How do we get these actual intercepts that sort of like circumvent some security features, but not all security features? And that is a problem. I think I'm just kind of starting to think about actually giving a lightning talk at CNCF Security Day Europe next month on this very topic, to kind of like socialize this a bit in the Linux community. So if you think this is interesting and cool and you want to add your 2 cents to that, definitely reach out. And I think it's important to point out that this is not like the volatility project's fault or the recall project's fault or the Lime project's fault or AVML's fault. This is the push and pull of security features, forensics, and attacks kind of all creating these symptoms in the ecosystem, right? And that there's just not enough kind of communication across those 3 domains and the actual like foundations to really provide these facilities. They do a great job, actually maintaining volatility for what it does. The volatility maintainers are actually the authors of that Art of Memory Forensics book, which has been, on my bookshelf forever. And, KASLR is a moving target. So Linux kernel continues to improve it. Windows continues to improve it for the purpose of security. And then also, as the memory forensics community advances, the formats that we have to store memory files in also are a bit of a moving target, and the tools don't really move lockstep because there's not kind of strong standards. So the one that you see on screen here, like a raw file, is just like a raw dump, and then there's the lime file, which includes some other information. The best one, I think, that's out there that's kind of got low adoption so far is AFF4, which is it's a container-based file system that includes that map information as well as additional metadata about the instance itself. If this was broadly adopted, it would actually allow analysis tools to have more kind of automation around how to find the kernel from obfuscated memory. But this still, even though it's an awesome format, still hasn't really been adopted in spite of being out since 2009. You know, the cycles just haven't gone into hacking this into every tool out there. So for now, I mean, you can collect memory, but you're going to go to it a lot less in these scenarios where you can't actually analyze it on the kernel variant that you're on. The best thing that we really have is live response packages, you know, kind of in a poor world where we don't assume that we're an enterprise with bottomless budgets to spend on security tools that warehouse live data outside of the system, which, believe it or not, is like the majority of startups and things. They're not investing heavily in every, you know, expensive security product that you can just sort of take off the shelf. So there's projects like Siler out there, which is a live response package that just kind of goes and gets volatile data and tars it up in a standard format that you can put in data lakes for analysis. It's not memory. It's not as good as memory, but it does give you a live data point. And once again, I'll point out that tools like these, they don't get live malware that only is resident in memory, not in files. They're going to give you netstat connections that you can correlate with threat intelligence, but you're never going to be able to kind of like break the case based on this data. You're going to have to go out to memory. Osler, another great tool that kind of takes the same approach as Siler, written by Forrest Monson. It uses the Amazon Systems Manager, which I'm a big fan of, to orchestrate kind of the same style collection at scale, warehouse that data in AWS S3, and then make a data lake. This works great, but it's also limited in what it's collecting. And then there's EDR. So when I talk about expensive solutions, and yeah, I know there's inexpensive free open source EDR. If you've had success at maintaining those for a staff of like 10, please let me know. But if you do have the privilege of being able to afford EDR, a lot of forensics workflow is moving to EDR. And for me as an examiner, this is terrifying because if you pwn the EDR, you destroy that single point of evidence gathering. And if you know of a case where EDR is like the sole chain of custody held up in a law enforcement related use case, definitely let me know, because I'm totally interested in existing case law with regard to this, because I think we need to start like kind of holding up where the rubber meets the road in case law, like versus defense strategies, because maybe we don't actually even care about any of this because a court has already ruled, you know, we don't actually need to care about memory forensics. We don't need the custody chain. All we need is EDR. And that's good enough if it employs XYZ cryptographic controls for the chain of custody around like a registry, let's say, as a contrived example. And then there's cloud control plane. So all the clouds out there, if you're in a cloud, GCP, AWS, of course, I put the AWS CloudTrail logo up there because AWS specialist. These only tell a piece of the story. They only show the pivots from the piece of malware that was in the enterprise. They don't tell how did that get on the box. They don't tell what else did it do to the box. They don't tell what it did to things that aren't specifically cloud APIs. And so strategies that are built on top of this also make me nervous, because a lot of people seem to hang their hat on this idea that if they're in a cloud and they turn on the cloud's logging, they can do forensics in the cloud, which is absolutely not true. You need the control plane logs, VPC flow logs, the sys logs, and then you also need this actual chain of custody for disks and mem on of the actual instances you run. And that gets harder and harder the more layers of abstraction you have. So if you're in a managed container environment, if you're in a Kubernetes, et cetera. It just gets more and more challenging to prove who done it. Good for attackers, bad for defenders, especially bad for forensics folks like myself. There are a lot of people like me that are trying to automate this. So put the Goldman Sachs guys up here on screen. They had a great talk at Forward CloudSec last year, automating disk and memory collection in AWS. I hope they can open source some of it someday. For now, it's just a great presentation for like kind of inspiring your process, and you can kind of see how complicated that automation can really be. All the different steps that we take that are sort of similar to in-person forensics at a cloud level, and kind of what they're doing to gain access. So you can kind of think about all the things that you could do as a attacker to kind of fiddle with that and make it less reliable. So here's that diagram again, just a little bigger. So we kind of go through this whole thing. I want you to pay special attention to the fact that they're taking care of disk forensics first in this, and then they're making sure they get their disk forensics off before they go to do a mem capture. And the reason for that, again, is this convoluted process that we have to go through sometimes to get things onto the box that kind of like taint the state of the system before we get a memory capture off. And so we have to be able to verify kind of like a before and after, and then show what we changed as analysts coming in doing forensics, memory capture, live memory analysis. So here's a link to that talk, and happy to share these in the chat as well, or share the slides afterwards. Stuff, these aren't not selling these slides. You can have a copy if you would like a copy. So like this kind of automation though is good. Like we want this automation. We definitely need this automation, but it relies on these linchpins, these fundamental tools in the industry that rely on these operating system facilities, and the two, once again, are kind of not talking to each other or creating standards for one another, and it has created this challenge here. So what can you do? We're just about done here. What could you do to help with this problem, either as an attacker or defender? So even if you're an attacker, I'd ask that you kind of do this, because it's just good for everybody. Attackers want to store stuff on bank computers too. So help the frameworks. You can do advocacy. You can go to these projects and you can look at issues that are relevant to ASLR and KASLR. Oftentimes, people who do these, sort of software maintenance projects, they just need to know that you want that feature. So like +1ing issues, identifying things that are common problems for you, filing the issues when you encounter them, super, super important. I, as a personal opinion, think this needs to go all the way to Linux kernel. And we actually need intercept facilities, lawful intercepts, I call them, in the kernel itself, or in systemd, or some of the facilities that live in the operating system to do this kind of forensics. I know that's bold, but we probably do actually need it. You can also do activism, make a tool that solves a problem. Like I tried for a while to make that kernel module warehouse. There's lots of code that will benefit somebody who tries to do that again. I learned a bunch of things. It solved the problem for a little while. It didn't solve the problem forever. Anything that automates building memory maps better than it is right now, it's totally things that need to exist. Anything that automates analysis of top 10s, like Siler, process mem, netstat, that gives us closer and closer to that, what we get from live memory. Well, having live memory as a fallback is also kind of a band-aid, not the final solution. And then packages, operating system packages like Kali Linux, for example, just dropped support for native Python volatility because it's based on Python 2. And of course, everything Python 2 is deprecated. It's very hard to get these tools backported into the platform for use, accessibility, et cetera. And there's not a lot of alternatives. So just becoming a packager of tools is a great way to be activist. Even if you're just like a sysadmin, you never built a Debian package, I promise you can. So kind of some of the conclusions here are that disk forensics once was thought to be so heavy that memory forensics was necessary. It's kind of gone full circle now, with some of it spinning out to EDR. Now it's kind of the last tool that a lot of the examiners I know use in the chain of whodunit. EDR is king for DFIR, but likely shouldn't be for all the custody and legal reasons that we discuss. And you, as an attacker, can easily stomp defenders' abilities to auto forensics by shutting down things like insmod, et cetera, by just kind of like writing things to the same locations that the defender would. Or in the case of AWS, where somebody's using a control plane thing to orchestrate that by stopping the managed agents or tampering with their ability to access AWS APIs, you can prevent evidence from effectively getting off boxes and covering your tracks. A couple other tools that aren't necessarily related to memory forensics that I think are opportunities if you want to build a cool open source tool is container forensics. It's a wide open space still. I don't know anybody that's doing container forensics open source stuff, either through parsing logs, memory analysis, et cetera. And then a few years ago, I don't know if you remember, there's this demo at DockerCon for this facility in Docker called CRIU, which is effectively like a hibernation file for Docker containers. They did a very cool demo where they took a Doom game and they spun it from one server to another on the same processor architecture. Well, that file is very much like a Windows hibernation file or like a vmem file. And as far as I know, there are no useful tools for being able to intercept that and also being able to parse those files for the purpose of kind of creating a whodunit inside of a pwned container. And that is a huge opportunity. The file format's actually pretty sane. If I had more time and different life, I'd probably just dive right into that. But love to see somebody pick those things up. Definitely, if you thought any of this is interesting, or even if you thought it was not interesting, if you thought this was the most terrible talk ever, please do tweet at me. I'm at Andrew Krug on Twitter, andrewkrug@gmail.com. Happy to field some questions at this point.
Hey, so Andrew, and thank you for your time. Thank you for the presentation. Amazing presentation. One thing that I guess I received a question, and I kind of paraphrasing because I think that this is what the person meant. Any thoughts on prefetch side attacks or side channel attacks to bypass SMAP and KSLR? Can they be used to overcome some of the challenges that you're actually facing in memory forensics?
Well, I think it's that's actually getting at the same thing that I'm talking about as far as like the dichotomy of defense tools and attack tools, right? So the easier it is to use side channel and SMAP to overcome KSLR for attackers, the easier it also is for forensics, right?
Absolutely.
So I would imagine that in my perfect world, the final version of this trust chain looks like a TPM backed version of being able to assert identity for those kind of side channel attacks, like sort of a sanctioned side channel, if you will. And whether that's a terrible idea or not, I don't know.
Okay, awesome. Now,
like I said, I'm not a hardware guy. I'm not an operating system guy. I've never written a single line of Linux kernel code. I'm a technical evangelist. I just have opinions.
Absolutely. Now, let's see. Checking Twitch, YouTube, 2 YouTube channels, and Discord. And I think that's the so there was the other question of, somebody that wanted to get started. Are there any like capture the flag type scenarios that you can do for memory analysis as well? Somebody was actually mentioning something that SANS did recently, that they have, I guess a couple of challenges that are posted in a GitHub repository. I'm gonna try to actually get that GitHub repository. Also, somebody was asking about where can they get AVML. I actually have the link, so I'll paste it in Twitch and YouTube.
Yeah, it's just github.com/Microsoft/AVML. Yeah. It's the SEO on AVML is good. If you just do AVML memory, you'll find the project. It really is like insanely fast compared to the alternatives. I was so surprised, and the compression is awesome.
A lot of things that are created in Rust nowadays are kicking ass.
Yeah,
yeah. Even offensive tools for for reconnaissance and everything that like Ferox Buster and some other ones are kicking ass. Super.
I once built a proof of concept Rust ransomware. It was scary fast.
Wow. Awesome. So I think those are the questions from pretty much everybody. And once again, thank you for your time. Appreciate your support. And with that said, I guess we'll see everybody next week. Thank you again for joining.
Thank you, Andrew. Really appreciate your time.
Yeah,
Great presentation.
Thanks for having me. Happy to come back, and everybody has my contact information. Please reach out.
Right. Yeah, definitely we will.
Thanks.
Appreciate it.